the last lecture video, we studied about the image sensing and acquisition. So now we'll see about what is the image sampling and quantization. So in the image sensing and acquisition, so we have studied like we're having an element or an object. So the light will be illuminated on the object. So we'll be having an imaging system will be there. So it will be light will be reflected, and reflected light will be absorbed by the imaging system, and it will be projected on a screen on the image plane. So that will be is nothing but it will be in analog form. So whenever you want to view it in a computer, so you have to convert that into a digitized format. So this will be your last figure. This will be your original figure, original image of the object what you're going to capture. So the simple image formation model, so there are the two-dimensional image. So any figure or any image can be given, can be notated by f of x comma y, where the value of amplitude of f at spatial coordinates is a positive scalar quantity. So in the before lecture videos also I told the x and y are the spatial coordinates, and f of x comma y together we will call it as the intensity of each pixels in that particular image. So it will be varying from 0 to infinity. So the value of the pixels can be ranged from 0 to infinity. It should be a positive value. So now we'll see about what is meant by image sampling and quantization. So here in the figure you could see that this is a continuous figure, and here you could see the digital representation of that particular same figure. So now any analog image, so that should be converted into a digital image with the help of a process called sampling. So this is same that we studied in the signal processing also. The sampling is a very important process that is used to convert an analog image into a digital image. So here there in the image signal processing we are using only sampling, but in the image processing we are doing the quantization also, because your image is a two-dimensional form. So there are numerous ways to acquire the image, but our objective is to generate digital image from the sensor data. So the output of most sensors is a continuous voltage form, so that you have to convert into a digital form. To create a digital image, we need to convert the continuous sensed image to digital form. That involves the sampling and quantization. So how to do the sampling and quantization? So here it is explained with the help of a very neat figure. So you could say that here it's a continuous image is there. Okay, so this continuous image, it is of different, it's a grayscale image is only shown over here. So this continuous image having different scales of different shades of grays, you can see that is from 0 to 255. So it is ranging from 0 black to the 255, that is white. In between that, different shades of different levels of gray levels will be there. So now how to do this? The first step to do this is to draw a line, or like you have to consider, you have to scan a line from A to B. The intensity level in the image will be varying. So you have to scan a line from A to B in that object or an image. So in that the intensity level should be varying. So in that from A to B, you could see that in near to A it is very darker intensity, that is very zero intensities, and in the middle region the intensities are very high. Again when it reaches to the B region, so the intensities are getting smaller, or it is getting darker. So now, so that is the first step. You have to scan a line. So in order to convert the image, so first you convert the image into a one-dimensional form. So now what you're going to do is you're going to draw, or you're going to plot this line AB in a plane. Okay, so that is nothing but a one-dimensional image, because AB is a line, so line is nothing but a one-dimensional domain. So when you're plotting it, you will be getting like this. So in this you could see that it is ranging from the AB, it is ranging because in that middle region you could see that like a bulging will be there, so that also is showing over here. So now you're plotting this in a one-dimensional plane. So you could see some random variations or some error kind of some random variations in this figure, so that will be due to the noise. Okay, you can eliminate that. So now, so second step is like what you have to do is, for that this is the first step. You have to draw a line, then you plot it in the one-dimensional plane. So now the third step is nothing but So for that, for doing the third step, you consider equally spaced locations at the bottom part of the figure. So you just consider, take this one-dimensional plane, and in that one-dimensional plane, you plot it in a scale, and you have to consider equally spaced locations in the bottom part of the figure. So consider these locations as corresponding to the spatial domain of the object. So now that is nothing but the sampling. Same thing what you're doing in the signal processing also. That is doing in the signals also. So that is nothing but the same, that signal, that is one dimensional thing. You are plotting in equal spaced locations, and you're dividing that into equal spaced locations. You are plotting near to the x-axis. So that is nothing but the sampling. So what we can call sampling in image processing? Sampling is nothing but we are digitizing the spatial domain. We are digitizing the spatial location. So the next, the fourth step is nothing but, so you know that your image is not only having the spatial coordinates, your image also have what? The intensity coordinates. Now what is the next step is nothing but you are digitizing your image in the intensity plane. Okay, so that is called what? The quantization. So the quantization is nothing but digitizing the sample in a intensity variation. That is called what? The quantization. So for the doing the quantization, so what you have to do is you have to consider an intensity scale at the right side of the figure. You could see that an intensity scale that is there in the right side of the figure. So it consists of around 8 discrete levels of intensity, that is ranging from black to the white, that is 0 to 1 or 0 to 255. So each sample is assigned with the corresponding intensity values, which is called what? The quantization. So now each intensity values in the line AB, that will be plotted against the variation in each intensities in the quantization level. So that is called a quantization. So now you will be getting a final image like this. So now you are quantized in the x-axis, you are sampled in the x-axis, and you are quantized in the y-axis. So this is the basic simple steps of the sampling and quantization. So now we'll see in the figure one by one. So figure shows the continuous image. If we want to convert into digital domain, an image will be continuous with respect to x and y coordinates, also in amplitude. So digitization of the coordinates value is called what? The sampling, and digitization of the amplitude value is called quantization. So for that you have to one-dimensionally have to plot a line AB. The random variations in the figures are due to the noise. So the sample points are indicated by a vertical tick mark in the x-axis. Okay, the samples are shown as white small squares. You could see that a white small squares that correspond to the vertical ticks in the x-axis. So now in the quantization, you have the continuous intensity levels are quantized by assigning one of the 8 values that is assigned in the each sample that you could see over here. Okay, this one. So the digitized sample resulting from both sampling and quantization is shown over here. So this is your original image, okay, that is an analog form, and this is a continuous form. And when you're doing the sampling and quantization, your image will looks like this. Okay, so this is all about the sampling and quantization. So I hope you understood what is the basic things in sampling and quantization. It's a very simple process. So you have to take an image and you have to scan a line AB in that image. Now you have to plot that in a one-dimensional scene. Okay, now in that next what you have to do is you have to plot the vertically equally spaced coordinates or the equally spaced locations in the bottom part of the thing or the x-axis. Now you have to plot each x-axis, each coordinates into the help that is there in the figure, and next you have to do in the quantization, you have to digitize the intensity with the level of 8 different intensity levels, and you then finally the image will be getting a digital image. So this is nothing but this is for one image AB. So like this what you have to do is you have to scan this line AB for the entire duration of the whole image. Then when you're comparing everything, you will be getting what? The digitized version of the image. So I hope you understood what is meant by sampling and quantization.